Right, here we go. Right, good evening, everybody. I hope everybody is well on this Thursday evening. So I'm just letting everybody in as always, just so that we can all settle down and make sure that we are in the chat. So just wait for more people to gradually come on in, which is a good turnout for tonight, which is great. So guys, I just wanted to thank you all very much for being so patient with me, especially the past week. There's been lots of photography things going on, especially in the astronomy world, which meant I was quite pushed to get a workshop done as promised by last week. So I do appreciate that all you guys have been so, and I hope we can do that tonight. I do appreciate that a lot, so thank you. I'm just going to let it roll for a couple of minutes if anybody into the chat. Just yourselves, I can just hear a bit of background noise, but just for a minute, just to do a bit of a quick hello to everybody. So I hope you've been at the night sky or as much as you can, especially in the past weeks of interest. Really good. So yes, there is lots to see. Right, so tonight, as you gathered, astronomy is a bit of a tricky one around the summer months. So what I like to do is to look at the sun, and yes, it is possible to look at it safely. So we'll be discussing that in this evening's event, just as we wait for a couple more people to come on in. So we're hoping, guys, that this might well be one of the last virtual astronomy workshops for Space4All, where we're all beginning to have our jabs and eventually government restrictions are being lifted, but more on that at the end. So we'll just wait for a couple more people to come out. We've got quite a nice turnout, actually, so thank you very much, guys. So just to those of you who have just recently joined, hello, it's lovely to see all of your recent faces. So just to explain, guys, look, thank you so much for being so patient as you have been, especially over the past week or so. I've unfortunately had quite a lot of photography commissions going on, so it's just been a bit difficult to try and fit in the workshop as well as promised. So just to reiterate that, guys, just to thank you guys for your patience before we begin with this evening. So I've killed just a little bit of time there. So what I'll do is I think we will begin with the presentation. So I'll just get my share screen sorted out very quickly and to see why this is being a bit tricky at the moment. Let's have a look. Okay, and then we want to do this. Here we go, share screen. Gorgeous. Right, okay, this looks good. So guys, just so I can see you on my screens, just give me a thumbs up if you can see the Space4All logo, just as usual. I just like to double check that in case there's a glitch, which is always good just to be careful about anyway. Okay, right, so the time, guys, is 3 minutes past 7. So I think we will crack on with tonight's event. So let's put this into the present tab. So we're currently filming on YouTube as well, guys. So for anybody who's tuning in from an outside source, just to say hello to you as well. So here we go, the next installment of the Space4All virtual astronomy workshops. So we'll be looking at the sun. So guys, with the summer solstice being fairly recent, we haven't exactly had, you know, very long periods of the night to be able to observe the stars. So as astronomers, what I love to tell people about is that it's actually possible to safely observe the sun. So whilst we've got the longest days and the shortest of nights, we can observe our local star, the sun. But tonight we will be talking about the precautions you need to make to observe the sun safely so that you don't dazzle your eyes for the rest of your life. So on that note then, let's begin. So I've just reiterated, guys, just as before, if I could just ask everybody just to double check their microphones to make sure that all you guys are muted, and I'll try and display this workshop in the best way I can possible. as always, again, if you guys have any questions whatsoever, however big or small, please use the chat tool or in your Zoom icons below and just begin it with the word question, just so I can pick that out at the end whilst rushing on through so I can answer that to the best of my capacity. You can also use the raise your hand tool. So I'm just trying to monitor this tab at the top of my screen. So if anybody's flagging up and is suddenly like, Josh, that didn't make sense, I can just have a little flick through, see how you guys are getting on and whether that makes sense or not. So we just have Sheila entering the call now. So I'll just invite her in very quickly. And let's have a look. I believe Sheila's now in. So just to say hello, I think Sheila's just coming in. So I think we'll begin now with our usual bit for the astronomy workshop. So as always, for new members here, my name's Josh Jory and I'm the founder of Space4All, which is an astronomy organisation devoted to practical astronomy and engaging members from all backgrounds to teach the basics so that we can all learn the night sky together. And in the process, by learning the basics of the night sky, we can learn how the effects of, say, light pollution and mega satellite constellations are having an impact on the natural world and is inevitably a resource, which is the night sky, that we are currently losing. So why we need to recognize its importance. And as we have recognized, especially through the past year, as to how the night sky has kept all of us connected through these very unprecedented times. So I think it's just been a useful resource, just even if it means being able to say hello to fellow members, even if it's through a virtual presence. So let's begin with the next slide. So the sun, our local star in the center of the solar system. So guys, you have to remember the sun, as our ancestors would have observed it, brought warmth, fertility, and life to our landscape. The sun at the center of our solar system, our unique place in the universe. And with our local star being so bright, and you may have catch just a glimpse of it as you do on a hot sunny day, you'll think, oh, that's a bit bright, that's dazzled my eyes. But using the appropriate astronomical equipment, it is actually possible to observe it safely. So I'll just reiterate that in this evening's series of events. So what I like to do is just provide a few solar stats just to understand exactly what it is that we're discussing today, and for new members as well. So I've tried to keep it as basic as I can, but I'll just chat through it. So it's just as basic as I can describe it to you guys. So the sun at the center of our solar system, it is a local star, which is exactly at the center. So if you imagine, this is 750 times the mass of all the solar system planets. This is big. You imagine that the core temperature of our local star can reach somewhere within the region of 15.7 million degrees centigrade. And for those of you who measure this in Fahrenheit, it is the equivalent of 28.3 million degrees Fahrenheit. You will roast if you are this close to the sun. It is a hot object in the solar system. It's what we know as a red giant at the moment, just for those of you who are a bit more advanced in the astronomy world. So what is producing the heat that we see, for example, on this June summer's day? It's basically nuclear fusion, the interaction of gases. As you can see in my description, it is hydrogen and helium, which is producing such heat. But this is also being escaped in the form of light and radiation. So if you imagine that streams of particles are generated through the solar wind, they are being blasted through the solar system. And just by our unique place in the solar system, we obtain these effects. We are in the Goldilocks zone where we are able to support life here on Earth. So what's also interesting as well is that this energy and temperature has been constant for approximately 4.6 billion years. So this seems like quite a long time, and is set to remain like this for another 5 billion years. So guys, don't worry, the world isn't going to end tomorrow. We'll be able to live our lives, but it's just within the next 5 billion years that eventually the sun is going to grow larger and larger and larger, and then eventually will obscure the innermost planets of the solar system. So basically, don't panic yet. So let's move on. Right, now we need to get down to the serious things, just ignoring the happy face in the corner of my screen. But when viewing the sun, guys, I must re-emphasize this. The sun is an incredibly bright object. So please, whatever you do not look at the sun directly. It will create a retina burn on your eye. You do not want to be using sunglasses. Even though they are a form of UV protection for your eyes, they are just simply not adequate enough to filter down the necessary amount of sunlight so that it is safe for observing. Don't, whatever you do, use an unfiltered telescope, because telescopes, when you're talking mirrors of about this big, they can be focusing this light down. It concentrates it. You want to be careful because it has the capacity to burn your retinas. And I have to mention it just so you guys are aware. I remember going to an astronomy organization quite a few years back now, and there was a chap with an eye patch. And we were talking about the sun, and he was saying, oh, well, the sun is the reason I've got this eye patch. And he explained that where he didn't have a solar filter properly attached, I don't need to explain it anymore, do I? So just please be careful. And also, the same principle applies with binoculars. You want to be the same with this because it does have the same impact. It focuses and concentrates light. So that's the only serious bit really in this presentation tonight. But we're going to now move forward on how you can safely observe the sun. So first of all, for anybody in the astronomy community, you'll see these and think, oh, these fun things, aren't they? Great. So basically what they are literally solar eclipse glasses. You tend to use these around the times of, say, partial, annular, total solar eclipses, and they are literally done to do just that, to safely observe the solar disk. So I'll just talk through them. They're quite funny, these things. I've always thought they were. They're made of cardboard, and they have all this instruction just on the inside. But these black areas you can see here are the very important pieces of solar paper, as it were, solar filters. And it's this sort of material which blocks out an extensive amount of light so that it is safe for our eyes to adapt and to be able to observe like the features we see in eclipses, like the partial phases, like what we guys would have seen on June the 10th earlier last month. So I was using these quite a fair bit at the time, but they are good fun. You can buy them on eBay. I think you can get something like 3 packs now for a tenner. So they're really good if you don't want to really use astronomical equipment and just to appreciate it where it is. This is really cool, and yes, I know it looks like a piece of tinfoil, doesn't it? Don't go down the supermarket and buy a piece of tinfoil. That isn't gonna work. What this is, guys, is literally called Bader solar filter paper. So just for you guys, in case you're making any notes, Bader is spelt B-A-A-D-E-R. And you can buy this from most astronomy shops and stocks anywhere, really online. I think when I last bought a piece, it was around £30 it's retailing for a piece of A4 paper inside. But the idea is this is the all-important solar filter material. So this blocks out around 99.99% of light so that it's safe for our eyes to adapt to and see. Now, the idea with it is, it's literally like a sandwich. So if you imagine you have two pieces of A4 paper, just like this solar filter paper is literally squished in between the two. And the idea is, using a pair of scissors, you can cut it down to shape, and eventually you can turn it into a solar filter just by using simple pieces of cardboard and mounting that around, say, a camera lens or an optical tube assembly, like a telescope and binoculars as well. So it makes them safe to observe the sun. I totally recommend having a little look, and if you want me to discuss it more, guys, I'm happy to flip my screen so that you're able to have a look with me online and do a little bit of online browsing and shopping. So these are more adequate solar filters, and to be honest, they are much more expensive. These, what you're looking at here, can cost in the region of hundreds of pounds, depending on how big a solar filter you get for your optical tube assembly. But the idea is, these literally fit on the front of your telescope. So you can see the screws here. You buy one really for the type of model of telescope that you're using, and you literally insert that over the front of your optical tube. You screw it into place so that it stays in place. So they're good to go for, although I tend to find they don't give as much contrast as to the solar filter paper that I was describing earlier. So if you find the more flimsy material, like as described in, if I can go back, nope, you don't want to look at that yet. This, you can get much more contrast. You can see more details on the solar disk. So really, going forward, guys, I totally recommend this. But just going back to this one again, if you guys ever look up YouTube videos on making a solar filter, whatever you do, tape it down, because some people, they put, the solar filters on the front of their telescopes, and during a windy day, it might blow off, and then it defeats the whole objective of using a solar filter. So just make sure it's strapped down, even if it's not a windy day. Strap it down so that you know it's in place and you can safely observe the sun. It's, an experience like no other. I've done it, quite a few times in the past now, making your own filter, and then suddenly, you see this bright disc whilst looking through the eyepiece, and it's all safe to observe, and you think, wow, that's our local star, the sun. It's fascinating to see. So let's move forward then. We've looked at this. Now, for the more avid astronomer, you can buy special solar telescopes. So I used to own one of these, and this is particularly called a Coronado PST. So for those of you who are thinking, Josh, what are you talking about? I'm looking at a really small, weird-looking telescope. This is a German-designed telescope. So it meets particular optical standards, within the European Union. But the point I'm getting to is that it's all adapted for safe solar observing. It isn't designed to look at the planets or other solar system objects, even the stars. It's purely just for the sun. So this particular model that I found out here is called what's known as a hydrogen alpha telescope. I know it sounds a bit techy, and we're going on the verge of, oh my God, what on earth's hydrogen alpha? I will explain all. I've got a couple of slides coming up just to show the difference. But basically, guys, the most important thing to remember is that these telescopes are adapted to look at a particular wavelength of light, which allows us to observe these details. There's loads of filters inside of this brass tube that you see, which flicks through these layers of sunlight, and then you use the eyepiece to observe the sun safely. Coronado is a brand of telescope. They're really good. They've got an amazing reputation for especially solar astronomy, and PST literally means personal solar telescope. It's a brand, basically. Moving on then, this explains exactly to what capacity a hydrogen alpha telescope is capable of. This is a photograph taken through a hydrogen Alpha telescope. How cool is this? Not only are you seeing a massive orange orb on your screens, but study it carefully. Look at the details that you can see on the solar surface. We will describe all the various counterparts as we go along, but for me personally, and it's all subjective, it's just my own personal views, but hydrogen alpha, I believe, reveals the most amount of detail, especially when the sun is very active. It's possible to see lots of materials being spewed off into space. You can see these change over a period of hours as well. You can literally be sat, in the garden with your solar telescope, drinking an ice cold drink and taking the casual view through the eyepiece and think, wow, you can actually see features changing on the surface of the sun. What's also interesting to note, guys, I should have mentioned this earlier actually, but just thinking about it, where the sun is so far away from us in the solar system, it takes 8.5 minutes for that light to reach Earth. So what you're seeing through your telescopes is a projected image of the sun as it was 8.5 minutes ago. So even when observing our local star, we are not seeing things at the very instant we look at them. Just reflect on that. That's a very, very weird perspective. This is a complete opposite. I know, a purple sun. This is a bit weird, isn't it? Why are you, Josh, like, why on earth are you showing me a picture of a purple solar disk? This is observed through another wavelength of light. So this is called A. It just simply looks through this other wavelength of light. So you've got hydrogen alpha, and then you've got calcium K just here, and you're literally looking through into a different source of light. But the point I'm getting to is you can observe more details in what's called the chromosphere, which is what I'll get onto in just a second. We look through another layer of the solar disk. So in this instance, you're looking at filaments, you're looking at granulation on the surface, and more noticeably, sunspots, but we'll get onto those in just a second. Right, and oh, these are so fun. Like, I tell you what, for a bit of fun, put your hands up, guys, if you've ever tried the projection idea with solar astronomy. I certainly have. It is so fun. You guys might recognize this when through solar eclipses anyway. You literally hold something like a colander up to the sun, and this creates small miniature projections of the sun. So it's a bit like pinhole photography for those of you who are interested in it. And especially during a solar eclipse, where so much of the solar disk is obscured, you'll begin to see all these individual partial phases through each of the holes on your colander. It is so, it's so interesting to look at. And there you are, you can see a picture of it too. Totally recommend it for the next solar eclipse whenever we may have it. It's well worth a go. But what's also interesting as well, the same principle applies if you're walking through a shaded area of trees or woodland, and you'll get loads of projections of the sun. This is really weird, and it's noticeable around sunset as well, if you have beads of light shining through the trees, and you can see loads of individual projections of the sun. So in this instance, it's clearly obvious that a partial solar eclipse, at least, is taking place. And this particular photographer's got their phone out or similar and photographed a shaded area. So you can see loads of projections of the sun across the floor. It's quite a strange feature to see this, but I've never seen it myself, unfortunately. I've just been rushing around trying to get cameras ready and panic if a total eclipse is happening. So it's something else just to bear in mind. Right then. So, things that you can see on the surface of the sun. So the surface really composes of what is called granulation. So this is where areas on the solar disk are literally within warmer and cooler areas, and they're bubbling up. This is the lava, or rather the masses on the surface of the sun, and you can see them change. They coalesce with one another. It's a very granulated surface, hence the name granulation. It's really bizarre to see, but it's just such a, you know, fascinating thing to look at, especially if you did ever try for higher magnifications. But again, just be careful if you do this. Even with, say, a 24 mm eyepiece, you're able to resolve granulation on the surface, and it is well worth a look. It's one of the more easier features to see on the surface of the sun. Sunspots. Now, these are so weird. They are just weird. Like, the thing is, right, sunspots are literally formed when there's convection currents on the solar disk. So this is areas where warmer areas combine with cooler areas, and it turns these sunspots into much darker appearing areas on the solar disk. And they can vary in size and shape. So depending what's happening on the solar disk is dependent on when we can see features like this. So here's one comparison, okay? So we have an image of the sun that was taken on the 7th of April 1947, and another one on the 11th of May 2012. And here's two simulations, these black blobs, one which is representative of the size of Jupiter, and this little blob, which is the size of the planet Earth. Now, just soak that information in, and then you compare that to the sunspots right next to those simulations. You could potentially be looking at sunspots that are far bigger than our planet, and in some instances could be just as big as the planet Jupiter. And there you are, photographic evidence right in front of your faces. And this just proves how big the sun is in comparison. It's a big boy, this thing. And it's well worth a look, especially doing solar astronomy, to be looking on a day-by-day basis, checking if you're on websites, on Facebook, seeing if astronomers have found another sunspot, and you can compare the size to like what you're seeing in these simulations. It's fascinating. So just moving on then, just bring that one across. So another beautiful thing is called the chromosphere. So this is the thin layer of the sun's atmosphere, and you can typically see the chromosphere during eclipses. Hence why I've dragged up this image of a total solar eclipse, and it's this red rim that you want to look out for. Ignoring these red blobs, these prominences around the surface, is this red ring just around here. This is the thin layer of the solar atmosphere, and that is basically the outer atmosphere of the sun. This can also be observed in solar astronomy as well, which you can see just here in this zoomed up view of the solar disk. It's possible to see it, especially using hydrogen alpha telescopes, and you'll just literally see this very, very, very thin ring around the surface of the sun. It's a really interesting feature to look at as well. But by far, these are my most favorite features to look at on the sun. These are called prominences. So this is material which has been ejected and spewed off into space. But you can see different types of prominences, like this one. This is called a filament prominence. This is when the material is ejected and then it splashes back down onto the solar disk, as you can see in this loop structure here. But you also get radiated prominences, as you can see here. This is when the material has literally erupted and it creates these weird flare looking shapes, as you can see in these series of images, but they vary from one prominence to another, just as it's being spewed off here. And you can see some really interesting textures as well. But what I love with looking at these in particular is that you can observe these changes over a matter of minutes, even hours. So again, if you're sat outside, cold drink in one hand, looking through your solar telescope, it's possible to see these things change shape. I've seen it Some astronomers have seen it as well, but again, just by taking time-lapse photography of the sun, you can see this weird changing shape on the solar disk, and they're really beautiful to look at. And again, like in that previous image, you can see these during a total solar eclipse when the moon has safely obscured the sun and these details become apparent. They're great to look at. So there's just those images again. This is cool. This is a representative image of the size of our planet Earth. And this is how big a prominence can be. These things are humongous. So I talked about this last time, guys, just ahead of June the 10th, but eclipses as well. So again, really important in terms of observing the sun. If you are lucky enough to see them, whether that be partial, annular, total eclipses, they're stunning to see. It's interactions within the solar system, and we really see the celestial dynamics taking place. They're brilliant to look at. I won't cover them so much in this workshop as I discussed that last time, but again, it's well worth a look when one's coming up. Now, these are very interesting as well. These aren't really relatable to surface features you see on the sun, but are just more events that you can see. These are called transits, which are very similar to eclipses in nature. But a transit is very similar to an eclipse, basically, but it's when a smaller object literally transits in front of the sun. So we have two comparisons here. I'll start with the one on the right, which you can see, and this black blob that you're seeing is actually one of the planets. This is the planet Mercury as it transits the solar disk. So this is just a photograph which would have been taken, say, every 20 minutes, half an hour, and you can eventually see the progression of this transit taking place. Another one that you can see is a transit of the International Space Station. So a human-made spacecraft which is currently orbiting our planet. And if you happen to be in the right geography, location, latitude, and so on, there's websites that tell you this out there, but using your local geography or location, you can find where your nearest transit is going to be. So basically, if you are observing the sun at this period of time, you know what time the transit's going to take place, and if the weather's clear, which in England is quite a rare thing, let's be honest, it's possible to witness a very quick glimpse of the International Space Station passing in front of the sun. So this astrophotographer here has been able to capture a series of frames where this has literally taken place, and as a result, has captured this beautiful composition of the space station right in front of the sun. This is also the same for the moon as well, but just to briefly mention that as we're going through our talk now. So what I've done here is I've got a YouTube video and it shows a time lapse of prominences. So I believe this YouTube video, which I'm about to briefly show you, demonstrates how prominences change in a small amount of time. So I'll just play this a couple of times and make sure that YouTube video is muted. But if you guys are watching this in real time and as if there's no problems recording this, you'll see the pattern of this, this prominence changing. So just take a moment just to look at that and see how this material is eventually being spewed out, falling back to the surface, and it keeps doing this. There's temperatures on the sun, which mean that it's radiating in the outer atmosphere, but you can just see it there. It almost looks like it's dancing, but in fact, this is a very violent feature on the surface of the sun. This is what eventually projects very strong solar winds, which is why we see the likes of the aurora borealis. So the northern lights, as they're known, this is all because of features like this, because of the interaction of the solar wind. Moving on, if I just get that video out of the way, please excuse me. You're going to think, what on earth, Josh, are you doing showing a green blob against a picture of an ocean? I love showing this image because this is in fact an optical phenomenon, and I love these things. They're called green flashes. So literally, guys, for those of you who may or may not understand what these are, green flashes are quite literally the interactions of sunlight through our turbulent atmosphere here on Earth. So as the sun is beginning to set, its light passes through dense regions in our atmosphere, especially as it reaches the horizon. And in doing so, you can see some very weird shapes and structures as the sun's setting, but eventually this light dissipates. And when it does, when you get that last fragment of sunlight, it's possible for just a brief moment to see a very bright green flash or even a very bright blue flash, although blue flashes are much rarer. And once I heard a rumor that, yes, you can only see a green flash from the Pacific Ocean. That is not the case, and I proved that wrong in 2017. I was on the top of the Mendip Hills in Somerset and, you know, out taking pictures, looking towards Glastonbury Tor. It was a clear day, just like as you can see in this image, and the sun was setting very low on this cold winter's day. And as the sun was setting, we began to see some strange things going on with the sun. It was tearing apart, and then suddenly, bang, you saw green flash. So what I'm trying to say, guys, is moving through the pictures, this is the view you might be able to see. So if you imagine this is the horizon, marked by these individual photographs, this basically demonstrates the light as it's dissipating through. So you can see the emeralds of green light and blue light as well, just highlighted here, but it's well worth a look. If you've got a clear, flat horizon, watching those last moments of sunlight, see if you can see a green flash. But really, to see a good, proper green flash, you need a flat horizon. So that's why I think, you know, there's speculation that you can only see them from like the ocean, say, because of its unique flat horizon. It's well worth a look. I'll just show this video very quickly, but I'll just go across. This is a beautiful time lapse on YouTube. Look it up. But this just shows you what I'm talking about. You see the Earth's atmosphere creating weird shapes, and then suddenly, just watch, bang, there's a green blue flash, and then suddenly we get this final bit of light. Look at that, green flash, and even a bit of blue. And this was taken from the Pacific Ocean, a brilliant view, and it's absolutely stunning. I'll just get that last clip up again very quickly. Look at that. So that is a green flash. Nothing really to do with the surface of the sun, but it's just if you're looking and it's a sunset, well worth a look. So moving on. So I always like to talk about, at this point in the talk, different types of resources that you can use to learn more about solar astronomy. And I like to relate to the resources that I own. And this one is a book directly from Patrick Moore's Practical Astronomy series. So it's simply called Observing the Sun with Coronado Telescopes. So you can see all the different types here in this image. You can find this easily through online retailers. If you guys go into Waterstones, you can pre-order the book and they can literally send it to your door, or you can go and collect it. But I think this book retails at around $9.99. It's a good resource to have, and it just explains to you in more detail just exactly what the purpose of Coronado telescopes are and why hydrogen alpha is a more favored wavelength of light in order to observe the sun. So I think it's a really good resource to have a look at there. So moving on. So we're coming towards the end of this talk. So I just wanted to say, guys, these are a series of resources that I currently have on my personal YouTube channel. So that's that Josh Jory Photo Media, just that hashtag at the bottom just there. When we eventually have a more established committee, I will be looking to recruit a series of members to sort of help us in our astronomical journey. So we might need some help uploading some of these current virtual astronomy workshops to our own YouTube channel, which is Space4All UK. It is currently a live YouTube channel, but you know, as a one-man show, it's quite difficult to juggle, you know, astronomy, your own, you know, working life and personal life together. So it'd be great to sort of work together as a collaboration to make Space4All a reality. So just moving forward. We also have our own social media channels. So you can follow us at Facebook, Twitter, YouTube as well. We'll have YouTube up and ready, and Instagram. So we're regularly engaging with members online as well. So it's well worth having a look at those guys just in case you haven't seen them. And just have a little look here. So now I will talk about what on earth is going on for the rest of 2021. A bit of a strange time, isn't it? You know, considering what we've all been through the past year, and I keep talking about this at the end of my presentation. So what we've covered already, the constellations, the planets, the moon, deep sky objects, celestial events, and now the sun. So guys, if it wasn't for the current government guidance, we could well have been hosting this particular virtual astronomy workshop in person. But as I'm sure you guys are thoroughly aware, because of this guidance, we are now currently delayed until July. So that means that I'm currently within my best efforts to plan our first public outreach event. So we do have a venue in place, but we're just waiting for confirmation of this date. And then as soon as we can let you know, me and the committee will let you know. And hopefully we can finally meet with each other once again, because it'd be lovely to see your faces. Like we've done so well survive virtually and to see all of your lovely faces and to be so lucky that you've attended all these talks. It does mean a lot to me, it really does, because Space4All was literally an idea free lockdown, and I thought, right, this is an aspiration of mine and I want to do something about it. So we need to make this happen in July or August, but it's more favorably looking at August. So what I'm going to do, guys, at this moment in time, I believe we could well be on for one more virtual astronomy workshop where we'll be looking at astrophotography. So this will be taking place in July. And the purpose of this workshop will literally be to teach you the basics of photographing the night sky. So I'll focus primarily on how you can use a digital camera. But if you guys want to know more information about how to photograph the planets from what you would have learned in February, or to photograph deep sky objects like that in April, then I will be able to teach you that in our next upcoming workshop. So I'm aware that I've currently, in the virtual program anyway, got it planned to look at the Milky Way in August. But as I've mentioned, at the bottom of the calendar, all of these events will be subject to change if and when current lockdown restrictions are eased. So this would be a lovely open and introduction event as a public launch for Space4All. So we can see who we can invite along and to see all you guys in person. So as soon as I have the information there and ready, we'll be able to host it in person. So fingers crossed that current guidance is going to be permitted. So guys, I'm going to get to that stage in the workshop where I take this off from, if I can do this very carefully, from this, and just take this one off very quickly. From my shared screen, let's see if I can get back to this and figure out what I've done here. And then we can have a look at a bit of Q&A. So just bear with me 2 seconds, stop my share. And has anybody in any capacity got any questions about this evening? If so, unmute yourselves and fire away. So just to double check, did anybody have any questions? Did anything not make sense whatsoever? If so, aha, yes, Phil, hello.
Hi, Josh, hi.
All right.
Yeah, thank you for another fascinating talk. Photographing the sun with a mirrorless camera.
Yeah.
how easy is it to damage the sensor if you're using a mirrorless? Is it?
Sure. Okay. So again, it goes back to this problem, Phil, of you need to have your telescope filtered. If in the pretend example you had a telescope pointing towards the sun and it wasn't filtered, and you've literally got all that light coming into the telescope, you have your mirrorless camera attached to the telescope, you are going to burn that mirrorless camera sensor out to a cinder. So let alone being your own eyes, it will literally burn it out. Literally, if you had a piece of paper in front of an unprotected telescope, this would set alight. So you want to be very careful. But the point I'm getting to is make sure that it's filtered with an appropriate solar filter. Make sure that whatever your optical element is, whether that be a lens even, just have it covered using the right material, and then you'll be able to photograph the sun safely.
Right. So the thing that always intrigues me, and I'm not clever enough to understand it, is the light obviously can burn a sensor, or as you say, a piece of paper, because it's focusing it. But if you cut the light out with the right filter, can the infrared radiation, the heat, not do the same? Because you're still focusing that radiation onto a sensor, aren't you?
I see.
Or am I missing it?
No, not at all, Phil. It's actually a very good question to ask. But again, this material, Bader solar filter paper, as it's called, is designed to be protected against UV and infrared radiation. So as long as it's protected over a surface, like say your telescope or a telephoto lens, and as long as it's protecting the all-important sensor, you're fine. I've literally done it a couple of times when photographing eclipses, and all you have to do to cater for so much light being reduced is literally to bump up your shutter speed, open your aperture if you need to, and literally also ping up your ISO values, and then get camera settings which work well for you, and you'll be able to snap away and see what's on the solar disk.
Right. Okay. So somehow that Bader paper, that filter, cuts out the light and the infrared heat.
That's right. Yeah, it's all German, optically designed towards European standards. So it's designed for both elements so that it's safe for visual use as well as for photographing the sun as well. Yes.
Okay.
I hope that helps.
Yeah.
It's a good question to ask, Phil. So yeah, thanks for flagging that one up. So yes, has anybody got any more questions, just to check and just flicking across the board to see if anyone's got any hands up? Otherwise, I'll give you guys a quick test then before we leave. So if you guys want to unmute yourselves, I'll give you guys permission to unmute yourselves right now, so that I can see all those red microphones turn off and I can see them all going across. Beep, beep, beep. Right, okay, guys. Hello, I can actually hear all you guys now. Have a bit of fun. So, what are, guys, the black blobs that you see on the surface of the sun?
Sunspots.
That's right, guys. Oh, this is great. I love virtual activities like this. What is the definition for material from the sun which is spewing off in space? It begins with P. Pa.
It's prominence.
Yes, go on.
That's the one.
There. What is the atmosphere of the sun?
Chromosphere.
The chromosphere. Did I just hear chromosphere? Did someone say that?
Yeah.
Brilliant. Well done, guys. So that's also important to remember. And what is favoured wavelength of light to look through when observing the sun?
Hydrogen alpha. Hydrogen alpha.
Hydrogen alpha, guys. Remember hydrogen alpha. The filter paper I was showing you is called white light paper. So it observes a particular surface detail on the surface of the sun. So it's just a little fun activity that we do together. I can just hear a bit of background noise, so I'll just quickly mute you guys up. So bear with me 2 seconds. So it's all good. Let me get this one switched out very quickly.
He's got a willow eye on my back.
Good fun, but hey, that's you know, Zoom for you, isn't it? Cool. All right, guys. So, guys, I hope that helped for this evening. And I just want to say as well, with the short notice that I had to give you, thank you so much for being able to attend tonight. It's very much appreciated. And as always, it's lovely to see all your faces. So for next month then, in July, we'll be looking at astrophotography, where I will teach you the basics of taking photographs of the night sky, so you can keep them on your mantelpiece when it's a cold, cloudy day. You've got that lovely picture of the sun to, or rather, the Milky Way to look at. So we'll have something to look forward to then. Otherwise, guys, that concludes the end of my talk tonight. So I'm happy for you to dissipate off. Otherwise, if anyone has any questions, they just simply want to leave in the chat or just to have a casual chit chat between one another, then I'm more than happy to do that as well. So just to say thank you very much, guys. So I'll just end the recording. Oh, it's quite funny on Zoom, isn't it? You have that American lady literally shouting, "Right, recording's finished," which is a bit of fun. Lovely. So, guys, feel free to unmute yourselves. But how did you find the talk? Was it a bit complicated, or did it make sense for you guys?
Really interesting tonight, Josh. Really enjoyed
Very
that.
interesting.
Yeah, oh, that's good, guys. I'm glad you liked it. It's really lovely to see, because I should do this more often actually after talks, but we've got people from far and wide. It's fantastic. We have Sheila Hampshire, just to say hello, who's joining us from quite far away. We have different people who are local, from local astronomy groups as well, which is really good. But we all share the same passion for astronomy, which is lovely, and the basics of stargazing. So it's just so lovely to see you guys all virtually on my screens, and just to say hi, see how you're all getting on, and just have a bit of a catch up afterwards as well. So have you guys been able to do much astronomy lately, or has it been, you know, weather hasn't been too good really?
The weather's been pretty shocking, isn't it?
Yes.
Unfortunately, it has, hasn't it?
Yeah.
Yeah.
Not very nice.
Yeah.
Hopefully it'll be get better from here on in.
It'd be really
Do you
good.
know, Josh, do you know if the Dark Skies Festival is going to go ahead on Exmoor this year?
In Exmoor, I believe it is. I'm currently not involved with it, so I'd possibly say, you know, if it's anything like other years, it went ahead last year, so I'm pretty certain by the time we've all had our jabs, we will literally, you know, be able to permit such events like that. So yeah, it's just waiting to see what happens really. Like, you know, I just wanted to briefly mention, you know, the public event, which is coming up, you know, in July, maybe August time, most likely for August, for Space4All, which would be really nice. But it's worth mentioning as well for members of, you know, Space4All who are further away and not exactly based in Somerset, I'll continue to do Zoom calls just like this. It'll be done in a different way to how we are currently doing them, because, you know, I'll have my laptop or whatever it is set up in a public space, still doing Zoom, connected to the internet. So even though we may not all be together, at least we've got a chance to still be there in person, whether that be, you know, physically, face to face, or virtually. So I just think it's important to mention that one as well. So yeah. I think Sue and Jack Jackson have got a couple of comments to say about that, but we'll wait and see how how that happens. Currently on the committee for Space4All, so it'd be really good to see what we can do further across the line, really. Yeah. Cool. All right, guys. Well, it was a short, brief chat, but lovely to see all of you. Glad to see that you're all doing safe and well. Lovely to see your faces. So we'll see you then for our next event, funnily enough, in the same month for astrophotography. So until then, wishing you cheers, guys. all the best, and thank you for coming.
Thanks,
Thanks a
Josh.
lot.
Bye,
Bye.
Josh.
Bye.
People, bye bye.